All right, y'all. So this is 7.4 quadratic equations. You know, for us, quadratic equations come in this form. Okay, so there's several ways to solve a quadratic equation. In your past, you probably solved these by factoring and other ways. But we're going to focus on the quadratic equation because it will solve every single quadratic equation if we use the quadratic formula. Now, first of all, there's new terms in this section. They use the word zero. And really, a zero is the solution to a quadratic equation. They're also equal to the x value of the x-intercepts. So they're equal to the x value of the x-intercepts. Okay, so in 4.8, we'll look at a graph and you'll see more of that, x-intercepts and solutions. But 7.4 is mainly going to focus on the quadratic formula. So to find the solutions of a quadratic equation, let me let some in real quick. All right, so to find the solutions of a quadratic equation, we can use the quadratic formula. And I sort of went over this a little bit the other day, but the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And we get a, b, and c from the equation. Now, the equation has to be in descending order with the x squared term, the x term, and then the number. And then that'll give me my a, b, and c that I throw into this equation, okay? Now, the quadratic formula can find real solutions and it can find imaginary solutions. And that all depends on this radical here. If the b squared minus 4ac ends up being positive, we'll get real solutions. If the b squared minus 4ac is negative, then we will get imaginary solutions. All right, so let's work some problems using the quadratic formula. So these will say find the zeros of the following function. All right, y'all, so they're giving us f of s equals s squared plus 14s plus 45. So you would take this equation, set it equal to 0. So what I'll do, I'm gonna figure out my 3 numbers. And then we'll plug them into our formula here and solve it. So A is in front of S squared. When there's not a number in front of the variable, it is definitely a 1. So that makes A 1 for this one. B will be 14. C will be 45. So y'all, we're now going to plug that into our formula. So we get X equals negative B, which is 14. So that negative in that formula, its only purpose in life is to change the sign of our B. So if B is positive, that negative is going to make it negative, okay? Plus or minus the square root B, which is 14 squared, minus 4 times A, which is 1, and C, which is 45. All of that is over 2 times 1. Now you'll notice a lot of our work is going to be sitting under this little radical here, okay? So let's just go through and simplify what we can. That's going to make that a negative 14. Plus or minus. 14 squared would be 196. Everything on this side is being multiplied. So there's only one negative. So that side's going to stay negative. And then we need to multiply to 4 times 1 times 45. That'll give me 180. All over 2 times 1, which is 2. All right, so continuing on, we still got work to do under the radical. Can't take the square root until that's a single number. So bring down that negative 14, plus or minus. Under the square root, 196 minus 180 is 16. All over 2. So y'all, now that we got a single number under the radical, we can now take the square root of that 16. So we'll get negative 14 plus or minus square root of 16, which is 4. All of that over 2. So let me bring that up here. So I got negative 14 plus or minus 4 over 2. Now, notice all 3 of these numbers will divide by 2. So I'm going to reduce everybody so that I get negative 14 divided by 2 makes that a negative 7. Plus or minus 4 divided by 2 gives me a 2. And then on the bottom, that 2 divided by 2 is just 1. And remember, we don't have to write the 1 since it's on bottom. So now we use this to get our 2 answers. The first time we do negative 7 plus 2 for the first answer. Then I'll do negative 7 minus 2 to get my second answer. So that's what that plus or minus is. We add 2 the first time, and then second answer, we subtract it. So I got negative 7 plus 2, which will give us a negative 5. And then we got negative 7 minus 2, which will give us a -9. So in MATLAB, it'll say x equals, and then we'll just put in our two answers, -5, -9, and be done. So, questions on that? Okay, also, we're just going to work a few more and then we'll knock out our next section. So we got f of x equals x squared minus 6x minus 4. So remember, I got to set this equal to 0. And it's probably why they call the solution zeros, because you find them by setting it equal to 0. So here we go. Find A, B, and C. Once again, there's not a number up front, so that's going to be a 1. B will be a -6. C will be a -4. All right, we're going to plug that into our formula. -b, which is a -6. So see, the negative is going to change this -6 into a positive. Plus or minus b squared, so that would be -6 squared minus 4 times 1 times our -4 all over 2 times 1. Now, where I get a lot of mistakes, people don't put that -6 in parentheses. And if you don't put the -6 in parentheses when you square it, it'll give you the wrong sign. Anything you square has to become positive, okay? All right, also, here we go. Double negative makes that a +6, plus or minus. -6 squared is 36. Now this side, -4 times 1 times -4. You got two negatives, so that's going to make that a positive this time. And then let's see, 4 times 4 is what, 16? All over 2 times 1, which is 2. So notice this thing's sort of like a puzzle. You got to get all the little pieces and then finally get those answers. So now we're going to add those numbers under that radical. So 6 plus or minus 36 plus 16 is 52. All of that over 2. So y'all, the trick now, to go any further, we got to be able to simplify that square root of 52. So on the side, I'm going to do some side work. And I'm going to simplify that square root of 52. Now remember, the other day I gave you the perfect squares. So let me just write them real quick. So I'll go up to 15. So 225 is 15 times 15, 14 times 14, and so on. What I need to know are remember to simplify this, I got to break out any factors that are perfect squares. So are any of these numbers, now we don't have to worry about 1 because that's not helping simplify anything. And that's a 52. So anything over 49 definitely is not a factor of that 52. So are any of these numbers, 4, 9, 16, 25, 36, and 49, are any of them factors of 52? So let me pull my chat up. So yeah, Claire, I would go 4. Now, I'll tell y'all, most of the time it's going to be 4 or 9 on these, okay? But 52 will divide by 4. So that give me 4 and 13. All right, so the reason we picked 4, because the square root of 4 now gives me a 2 square root of 13. So I can replace that square root of 52 with this. So that's going to give us 6 plus or minus 2 square root of 13 all over 2. Now, for this to simplify any further, all 3 of these outside numbers have to be able to reduce by the same number. And y'all, I got 6 and 2s. They're all even numbers. So that means they'll all divide by 2. So 6 divided by 2 will give me a 3 plus or minus. 2 divided by 2 leaves me a 1. So that'll be a 1 square root of 13. And then on bottom, 2 divided by 2 leaves that a 1. So we don't have to write the 1 on bottom. So Math Lab will take that answer right there using the plus or minus. But if you wanted to break them down into 2 answers, the first answer would be 3 plus square root of 13. The second answer would be 3 minus square root of 13. But yeah, Math Lab will have that plus or minus button. So you could punch it 3 plus or minus square root of 13, okay? Well, y'all, that's a trick. Notice most of our work is in the radical, okay? And trying to get that radical simplified. Once it's simplified, then it's just a matter of reducing stuff if we can and getting our final answer. All right, y'all good on that? We're going to move to our third one then. Now 3, let's see what they want. They want me to find the zeros. They want me to give exact answers. So exact answers means using the radicals. And then it wants me to find approximate solutions, which will be like decimals. So yeah, Kara, for y'all in this section, there are always going to be 2 answers. Usually you can tell how many answers you get by the exponent. So these have x squareds, which have exponents of 2. We're going to get 2 answers, okay? All right, so on this one, I won't find exact answers. Also, we're going to find approximations. And these, they want 3 decimal places. So I'll get the exact answers first, and then I'll show you how to punch it in on your calculator to get these decimal places. So here we go. We'll find A, B, and C. A is 1 again. B will be 3. And C will be -7. So let's plug them in. Negative B, which is 3, plus or minus square root B squared minus 4 times A, which is 7, C, which is -7, all that over 2 times A, which is 1. All right, so let's have some fun and get this thing going. So let's go make that a -3 plus or minus 3 squared is 9. Now remember, we're multiplying -4 times 1 times -7. There's 2 negatives, so that's going to become a positive. So 4 times 1 is 4, times 7 is 28. All that over, 2 times 1, which is 2. All right, y'all, so still we got to add under the radical real quick. So -3 plus or minus square root 9 plus 28 is what's that, 37, all divided by 2. So let's do our side work and see if we can simplify the square root of 37. So y'all, do any of my perfect squares, are there any of those that are a factor of 37? So try your 4, 9, 16, 25. 36 is probably the highest you got to go because that's under. So Karen, y'all said no. Good job. This one does not simplify. So since that does not simplify, that right there would be my final answer. Okay. And y'all, that even if there's numbers out here that'll simplify, if you don't have a number in front of that radical that'll simplify with those, you can't go no further. So remember, this would be -3 plus square root of 37 over 2, -3 minus square root of 37 over 2. Now, here's the big thing about this. We got to find decimal approximations. So first you'll put in these and then it'll ask you for decimal approximations. When you do this on the calculator, we got to put parentheses around that numerator. So put parentheses around the numerator. So we're about to go to my calculator and I'll show you. All right, so on my calculator, I will do parentheses, -3 plus square root is the second x squared button, and then put in your 37. Now arrow out from under that, close the parentheses, and then divide that by 2. So y'all, you got to have it in parentheses. Now we're going 3 decimal places. So y'all, 3 decimal places on that would be 1.541. So that stays a 1 because the 4th decimal place is a 3. And remember, it's got to be 5, 6, 7, 8, or 9 for me to round up. If it's 1, 2, 3, 4, or 0, we leave it the same. So that 1 stays a 1 on that one. Now to get the second one, I'm going to do my parentheses again. -3 minus second x squared to get the radical. Put in a 37, arrow out, and close parentheses, and then divide that by 2. So my second answer will be -4.541. So notice when you round 3 decimal places, they're talking after the decimal, okay? All right, but notice they're sort of similar. They both got that 54138 part. The only difference is the 1 and the -4 on those. All right, so that's all I did. So you put in your 2 decimal approximations, and then it's time to move on. Y'all got questions on that? So let me ask y'all this. Are any of y'all on here, did you download the programs I got y'all for your calculators that I sent in the email? So all y'all are doing these by hand, huh? All righty, so let's keep going by hand then. So now these ain't bad by hand. Number 4, f of x equals 4x squared minus x plus 3. Y'all, let me show y'all. We'll do this by hand, and then I'm gonna show you what the programs will do. Because if you need to, I'll resend them programs, at least this quad one, okay? All right, so set this equal to 0. Now, y'all, this one says express complex numbers in terms of I. What they mean, they want these to look like this, A plus BI, when we have our real part and our imaginary part. Now, they want them expressed in terms of I because they don't want us to have any negative numbers under the radicals, okay? So A is 4, B is -1, C is 3. So let's plug that in our formula. X equals -b, which is a -1, plus or minus square root -1 squared minus 4 times A, which is 4, C, which is 3, all over 2 times A, which is 4. All right, y'all, so let's see. Negative makes that a +1. Plus or minus. -1 times -1 is +1. Now, y'all notice this time on the right side, there's only one negative, so it's going to stay negative. 4 times 4 times 3. Let's see, that'd be 16 times 3. That's what 16 times 3 is 48. All over 2 times 4, which is 8. All right, so we're getting there. We still gotta figure out underneath our radical, remember. Gotta get it to one number before we can simplify it. So we got 1 plus or minus square root. 1 minus 48 now gives me a -47 all over 8. So now we got to try to simplify that radical. So I got a square root of -47. So let me ask you all this. Are any, okay, so you already got it. It won't simplify as far as the numbers go. But y'all, we do got to take care of that negative. So y'all remember what I did with the negatives. All right, so remember, we can't keep a negative under a radical. So we're going to split this into a square root of -1 times 47. All I did was break out that negative as a -1. Do y'all remember what the square root of -1 equals? Ah, there you go. So that this would become a I square root of 47. So remember, if you got a negative radical, you got to bring that negative out because that now makes this an imaginary answer. Because in the real world, I can't multiply two numbers and get me a -47, okay? So we're going to replace the square root of negative 47 with I square root of 47. So that'll give us 1 plus or minus I square root of 47 all over 8. And y'all, the last step to make it look like this, we need to split this apart since it's imaginary, which means each part of the top will be put over that denominator so that I get 1 over 8 plus or minus I square root of 47 over 8. That way you got your real part, which is the 1 over 8, and then your imaginary part, which is the I square root of 47 over 8. That is what MATLAB wants. So when they ask you to express complex numbers in terms of I, they want this to have the real part and then the imaginary. And that's why these are called complex numbers, okay? Because they got both parts, real and imaginary. All right, so that's probably the trickiest one because of the way you got to write this answer. So y'all, let me show y'all on that calculator so that maybe y'all can get this thing downloaded. So watch this. I'm gonna clear that. So I'm gonna go to my program. I'm gonna get my quad. I'm gonna hit enter to run it. So it wants my A, B, and C. So for the problem I just did, I had a 4 for A, enter. I had a -1 for B, enter. I had a 3 for my C, enter. So watch when I hit enter. It gives me the 1 plus I squared of 47 over 8, and then the 1 minus I squared of 47 over 8. So the calculator leaves them as fractions. On this problem, you would still have to split it apart. Y'all, it gives you the answers, right? Now, the next one I do, you'll really like the way the calculator does it. So let me go back. All right, so this one wants me to find exact answers and approximate 3 decimal places. 5x squared minus 7x minus 3 equals 0. So find exact answers. And approximate 3 decimal places. All right, so let's see. A is 5, B is -7, C is -3. All right, here we go. X equals negative B, which is -7. B squared, which is -7 squared, minus 4 times 5 for A, -3 for C, all over 2 times 5 for A. All right, so the negative, once again, made that into a +7. -7 squared is 49. This time I have 2 negatives over here being multiplied. So that's going to make that a positive. 4 times 5 is 20, times 3 is what, 60. All of that is over 2 times 5, which is 10. All right, y'all, so let's add that together. 7 plus or minus square root. Woo, that's going to give me what, 109? All over 10. So we need to see, y'all, if we can simplify the square root of 109. But that's on y'all. So can I simplify that square root of 109? Are any of my perfect squares factors of that? So good job. That does not simplify. So my final answer, since that doesn't simplify, is 7 plus or minus the square root of 109 over 10. Now I'm going to write it as two answers so that I can do these decimal approximations. So 7 plus square root of 109 divided by 10. And then we'll figure out 7 minus square root of 109 divided by 10. Remember, on the calculator, I will use parentheses. Now, I'm going to show you the power of that program that I have sent y'all. So y'all watch this. Program. I'm going to go to my quad again. A was 5. B was -7. C was -3. Now, when it's real numbers, it will give you the decimal approximations. So I get 1.744, and then I get a negative 0.344. Now watch this. That's the decimals. It always gives you the decimals first in the program. But when I hit enter, there's my two radical answers. 7 plus square root of 109 over 10. 7 minus square root of 109 over 10. All right, y'all. So that was 7.4. Do y'all have any questions on that? So let me look on my chat. All right, so I see no answer, no questions. So we're going to go into 4.8. And 4.8 deals with applications. And eventually, applications will mean word problems, okay? But y'all, let me show you how this starts out. So I'm just looking at these top two. This says use the graph to find the x-intercepts and then the solutions. So can y'all see that good enough to tell me the x-intercepts? Now, since they're x-intercepts, we got to put them in parentheses. So let's see, this x-intercepts is where it crosses the x-axis. So it's crossing right here at, looks like, -2. So that x-intercept would be -2, comma 0. Then you got to put another comma to separate the ordered pairs. This one is over here at what? 1, 2, 3, 4. Looks like 5. So that one would be 5, 0. So remember, the x-intercepts have to be ordered pairs. Now the solutions, if you remember, the very first thing I gave y'all in your notes, I said the solution to a quadratic equation is equal to the x value of the x-intercepts. So we got our x-intercepts, so that means the solution would be -2, comma 5. All right, so since I did that one, y'all get to do this one. Here's your parabola. Hopefully you can tell where it's crossing the x-axis. So one of y'all tell me what my two x-intercepts are. Oh, okay, so let's see. So that was a -1, so that one would be what? -1, 0. And then you got this one over here at 4. So that one would be 4, comma 0. And you're perfect, so that the answers are -1 and 4. And y'all, that's all these two problems want you to realize is that the solutions are equal to these x values of the x-intercepts, okay? And just remember, when you write these x-intercepts, put them in ordered pairs. All righty, so now we got the fun coming up. All right, so I'm just gonna, instead of writing this whole thing, we're just gonna read it. And then we'll draw our picture. So a wire is stretched from the ground to the top of an antenna tower. The wire is 15 feet long. The height of the tower is 3 feet greater than the distance D from the tower's base to the end of the wire. Find the distance D and the height of the tower. So y'all, let me show you what we got. So I've got me a tower here, an antenna tower. So I'll call that my antenna tower. And you got a wire that is stretched from the ground to the top of that tower. And then this would be my ground down here. They're telling me this wire is 15 feet long. They're saying the height of this tower is 3 feet greater than the distance D. The distance D is the distance from the wire to the base of the tower. So they said that was D. And then the height of the tower is 3 feet greater than that distance. So that would be D plus 3. So if you notice, this makes a picture of a triangle, and we call that a right triangle. So y'all remember a formula that helps you find the length of the sides of a right triangle? And I'll even give y'all a clue. The Pythagorean theorem, do y'all remember that? It says that a squared plus b squared equals c squared. There you go. Now, oh, you're good, sir. I seen what you got. Now, the trick on this, y'all remember what this longest side's called? Hypotenuse, there you go. In the formula, the hypotenuse always has to be side C. C has to be the hypotenuse. Now, A and B, it don't matter which one is A, which one's B. So I'll just call this my A, and then this side my B. So I'm going to fill in what I got for A, B, and C, and we'll work our Pythagorean theorem. A is D, so that'll give us a D squared. B is D plus 3, so that'll give us D plus 3 squared. That's going to equal C squared, which is our 15. All right, so the trick is this D plus 3 squared, so I'm going to do it on the side again. Remember, since that's a D plus 3 being squared, you got to write it twice and FOIL. So we'll get a D plus 3 times D plus 3. So here we go. D times D is D squared. D times 3 is a 3D. 3 times D is 3D. And then 3 times 3 is 9. Let's add like terms real quick. So that'll give us a D squared plus 6D plus 9. So we're going to go up here and replace this D plus 3 squared with what we just got. So bring down the D squared plus D squared plus 6D plus 9, all equal to 15 squared. So at that point, you can figure out 15 times 15, which will be 225. All right, y'all, so here we go. Add like terms on this side. D squared plus D squared is 2D squared plus 6D plus 9 equals 225. So I got a quadratic equation because I got a D squared term here. So my question is, what do we need on the right side of that equation? A 0, good job. Well, since I need a 0 over here, we need to subtract 225 from both sides. Well, here we go. We get a 2D squared plus 6D. Let's see, 225 and 9, that's going to give me what, a negative 216, all now equal to my 0. So guess what? I can now solve this using my quadratic formula. A is 2, B is 6, C is a negative 216. So here we go, y'all. X equals negative B, which is 6, plus or minus square root of B squared minus 4 times A, which is 2, C, which is negative 216, all over 2 times A, which was 2. So this boy is going to give me some big numbers, it looks like. So that's going to give me negative 6 plus or minus. 6 squared is 36. And y'all look over here. I got 2 negatives. So that's going to make this a positive. Woo, so let me figure out my calculator real quick. So we got 4 times 2 times 216. That's going to give me 1,728. All over 2 times 2, which is 4. All right, y'all. Add this together now. So we get negative 6 plus or minus. So 1728 plus 36 is 1764 all over 4. I'm going to tell y'all a trick. When you're doing this problem, that would be a perfect square. So y'all figure out what is the square root of 1,764. So let me pull this up. So square root 1,764. Let's hit enter on that. And I'm getting 42. So that'll be negative 6 plus or minus 42 over 4. So to get my first answer, I'm going to take -6 plus 42 divided by 4. That'll give me 36 divided by 4, which gives me 9. The second answer is -6 minus 42 over 4. That gives me a -48 over 4, which gives me a -12. So y'all, my question to y'all is this. How long is D? Now y'all remember, y'all got 2 answers here, right? So Kara, that's what I would go with. Remember, distance has to be positive. Distance can't be negative numbers. So when you're doing a problem like this, finding distance, and you get a negative answer like that, cross it out because it cannot be negative. That means D has to be 9. So you got to pick the positive answer when you're dealing with distance problems, okay? So if D is 9, my question is, so the distance is 9. Y'all, how tall is my tower? Well, how tall is this antenna tower right here? Well, good job. Because the tower was 9 plus 3, which gave us a 12. Good job. So 9 for the distance, 12. Now what's nice, watch this. On your calculator, if you do 9 squared plus 12 squared, that gives me 225. Well, guess what? 15 squared is 225. So your answers will all work out to check them once you plug them back in. All right, y'all, so we're going to do one more of these fun ones. Right, so read this one real quick and then we'll. So this one says, the foot of an extension ladder is 3 feet from a wall. The height that the ladder reaches on the wall and the length of the ladder are consecutive integers. How long is the ladder? So y'all, let me write that one out here. Well, let me turn this over. I don't like my pages flipping up. All right, so we got a wall here. And I've got a ladder leaning up on that wall. Now, the first thing they said, the foot of my ladder is 3 feet from the wall. So notice I got a triangle again. And they're telling me that that is 3 feet. Now they're saying the height the ladder reaches on the wall and the length of my ladder are consecutive integers. What they mean by consecutive integers, if we let this one be x, that means the next integer after x would be x plus 1. Right, remember, because consecutive integers are numbers like 1, 2, 3, 4, consecutive. So to go from 1 to 2, you just add 1. To go from 2 to 3, you add 1. So no matter what this integer is, to go to the next integer, you add 1, okay? So I guess I can use this again since I got me a right triangle sitting there. A squared plus b squared equals c squared. So y'all, which side has to be C for this problem? The 3, the X, or the X plus 1? Good job. Has to be the X plus 1. That has to be C no matter what. So this can be A, that can be B, or that can be A, and this can be B. They don't matter. It's just C has to be that hypotenuse, okay? All right, so let's see what we got. A is 3, so I'm going to square 3. B is X, so I'm going to square my X. That's going to equal C, which is X plus 1 squared. So we'll have to do a little side work on that. But first, we know 3 squared is 9 plus X squared. All right, so on the side, let's figure out X plus 1 squared. That'll be X plus 1 times X plus 1. That'll give us an X squared plus 1X plus 1X. And then 1 times 1 is 1. I'm going to add like terms real quick. So we get an X squared plus 2X plus 1. Oh, hey, y'all, I haven't seen the news in a while, but have they took care of that St. Vincent's issue in North Little Rock, Sherwood? Did y'all see that earlier? They had like a active shooter over there. So they got him already? Okay, good job. All right, so let me replace that right side with X squared plus 2X plus 1. So y'all see this is quadratic because of the X squareds, which means on one of these sides, I need a 0, right? So how am I going to move the X squareds to the other side? Well, we're going to have to subtract it from both sides, right? Because I need to get them all on one side. But y'all, look what happens when you subtract the X squareds. I get 9 on this side. These X squareds cancel. That's going to equal my right side. Those X squareds cancel. All that's left is the 2X plus 1. So since I had X squareds on both sides, they cancel out. So this is no longer quadratic. So since this is no longer quadratic, all we got to do is solve this for that X. Oh, you're so close, but I'll probably go the other way. Try to get that X by itself and get these numbers on that other side. So how about subtracting 1 from both sides? Because see what you did, Karen, when you brought it over, now you got to move the numbers back so you can do your dividing, okay? Because you got to have that X on that one side by itself. So this will give me 8 equals 2X. And then there you go, divide by 2 on both sides. So that X equals 4. Now here's the question they want to know. How long is the ladder? Well, remember, 4 is X. Oh, good job. Because that means this wall is 4 feet up on the wall where the ladder's hitting it. But the ladder, we said, was the X plus 1. So the ladder would be 4 plus 1, which is definitely going to give you a 5. Okay. So the problem with the wire, it stays quadratic. So you're going to have to use the quadratic formula to get those answers. The one with the ladder, when you're working it, it starts out quadratic, but the quadratic stuff cancels itself out. and it just becomes a linear equation with one answer. And that's why this one only had one answer, because we don't have those x squared terms anymore, okay? All right, y'all, I'm trying to pick up on the, okay, I got it now. All right, so y'all, that is everything. So these are not real long sections. 7.4 mainly focused on the quadratic formula. 4.8 focuses more on the Pythagorean theorem, although one of them still uses the quadratic formula, okay? So let me stop that share. So do y'all have questions over this? Y'all, let me catch up on that. What am I seeing in here? All right, so to be caught up with me totally by Sunday night, you want to have your 7.4.4.8 done. We'll come in next week on Monday and start 7.5, which deals with what we call the vertex formula. All righty, y'all. So one more time, any questions over any of this material? All righty, so y'all, I'm gonna let y'all go. Let me stop our recording.